Hello friends, today I'm going to talk about Leetcode 14.15, the case lexicographic string of all happy strings of length n. Here, a happy string is defined as it contains only A, B, C, three letters, and each two adjacent letter is not adjacent. So here we have this string. First type of strings, each adjacent letters are not the same, and they are only allowed to be fetched from ABC. So they are happy string. And all other cases are not happy string. Given the two integers n and k, we need to consider of all the happy string and find out the case string in lexicographic orders. So here is an example. Here n equal 1, k equal 3. We have n equal 1, so we have only 3 letters that are all happy strings. So the Swiss string is C. For second one examples, we cannot get more than 3 happy strings, so we return empty. For the third, we return the CAB because we can get 12, and the ninth is CAB, and etc. So seems this problem is that the first idea is that we can generate all the happy strings for the length n, and after that we can get the case strings fetched from the n. This is more direct and straightforward solution because the n is only constraint between 1 to 10, which is very small, and k is also 100 small. So this should be able to pass should be able to pass the solution. Should be the solution passed without time limit. We can actually secondly we can also optimize this solution a little bit. How to optimize that? We do not need to generate all the happy strings for the length n. We only need to find out the orders during the find the orders starting from a closest point position. And we have found that, for example, here if we have n numbers, number equal 1, we can generate a string like this A, B, B, C, right? If with n equal 2, we can generate A, B, A, C, B, A, B, C, and this C, A, C, B, 6 letters. So we can generate 3 times 2. And for if n equals 3, we can generate these 12 letters, right? So for this formulas, we can find that if we have n letters, we can generate 3 times 2 power n minus 1 letters, and as long as this letter is bigger and equal to n, we can return or valid happy strings. This is the total number of the happy string, and this is the case string that we need to return. And so it seems that for example, for n equals 3, k equals 9 here, we know that there are 12 strings. Actually, we do not need to generate all 12 strings from the ABC to the end CPC. We only need to start from over here, because the previous 6 we already know it is less than k equals 9. So we do not need to generate these 6. These 6 start with A and B. So we only need to start from the C. So this is the way we can optimize the solution here. So we need to only find the rank of the position that we need to start. So here we have the rank is we have 3 letters ABC. We only need to start from the C over here. So we can use a iterative way to solve this problem. In the way we need to find each rank and each partition numbers. The partition number is over to 2 powers n minus 1. That here is if n equals 3, here should be the 4, because each number is 4 over here. And then we found the rank. The rank is we can use the number of k minus 1 divided by the partition number, and in this iteration, and then we go for the next iteration. We need to update the rank and also update the k, right? So when we need to update the k, and when it goes in that situation, the rank will be updated by the new k. So it could be k could be updated by the modulo. That is the rest case strings x, and minus the previous this 6 string. So it divided by partition number here, and then we decrease the m minus 1 and decrease m by 1 here. So we go to the next iteration. In this way, we can continue to iteratively find the position as the letters we get into the result. So let's write the code over here. And first we check the corner case. If the 3 powers 3 times 2 powers n minus 1 less than k, we return empty, and we define some of the map over here. Like we have the for the initial we define empty. We have these 3 letters for rank. And for the A letters, we can only fetch the B and C for the next iteration. B and C. And for B, we only have A, C. For the C, we can only have the AB. And we define the current letter that is we use, that is current we start from empty, and you get the answer strings put into answer. We can put into a list first, because it will save a space for this operation to add each letters, and then we can transfer to the final string. Use the join operations for the string, because if we use string plus equal, every time it will create a new space. It is time consuming and also space consuming. So then check use iterative way to iterate this. And first we get the partition number. Each partition number we have this number, and we get the current rank we need to fetch the number here. Fetch the character. The next character should be from this, and we get the this rank is like for the first time. If for the k equals 3 and n equals 3, k equals 9, we have this rank is equal to 2, and we get current char is empty and rank is 2, so we get letter C here. We put it into the answer list, and then we update the current letters with this current C letters, because for last time we can only need to A and B, and update to the N, and also update the K. Since this is finished, then we also to update the final. If the n equal to 0, we still have the last one is not added, so we have to add it over here. And we return the answer. Oh, I didn't define the rank over here, so this is not the rank. This should be the it should be the K is already outdated. So k should be the last one, k minus 1 over here. Okay. This should not flow here. We do not have flow over here. What is flow 29? Current. Oh, this should be single carrier string over here. Not single string problem. Seventh is not the flow. Okay, this is something is wrong over here. Oh, this should be not flow. This rank is flow. We should divide it by the use double backlash to make it an integer. Okay, it works. Okay, we made it.